Good afternoon, everyone. I am Jithin Philip, College Coordinator from PSG Medical College, Coimbatore. Today, our topic is about the ventricles of brain. You all know ventricles are just cavities in the brain which are filled by the cerebrospinal fluid or the CSF and are lined by the ependymal cells. So, we'll look more into that. So, there are four ventricles of brain, two lateral ventricles, a third ventricle, and a fourth ventricle. The two lateral ventricles, one in each cerebral hemisphere, forms the largest component of the ventricular system. So, this one is the lateral ventricle. These are the lateral ventricles which are located in the cerebral hemispheres. The two lateral ventricles are separated from each other by a septum called the septum pellucidum. And this one is the third ventricle, which is a narrow slit-like cavity of the diencephalon. The lateral ventricles, these are the lateral ventricles, are connected to the third ventricle by the interventricular foramen of Monro. See, the blue thing is the third ventricle. It is located in the diencephalon. These are the lateral, the brown thing is the lateral ventricle. So it is C-shaped. We'll have more parts in the lateral ventricle. We'll study that. This is the lateral ventricle, which are located in the cerebral hemisphere. So you'll have right and left lateral ventricle. This is the third ventricle. This is the fourth ventricle, which is the green thing. The third ventricle and the fourth ventricle are connected by the cerebral aqueduct. The fourth ventricle is a cavity in the hindbrain. This one is located in the midbrain. This one is located in the diencephalon, narrow slit-like cavity of the diencephalon. So the third ventricle communicates via the cerebral aqueduct of midbrain with the fourth ventricle, a cavity in the hindbrain. See, this one is the fourth ventricle. This one is the fourth ventricle, which is a cavity in the hindbrain. This one is the third ventricle in the diencephalon. The fourth ventricle is continuous with the central canal of spinal cord. See, we can see that the fourth ventricle is continues with the central canal of spinal cord. The central canal extends till the conus medullaris. We will study more about the spinal cord and the central canal in the chapter spinal cord. The cerebrospinal fluid is formed in the ventricles by the choroid plexus and passes through apertures in the roof of fourth ventricle into subarachnoid space. This is the subarachnoid space. The CSF or the cerebrospinal fluid are formed by this one. The spiral thing is called the choroid plexus and the Tela choroidea. You will study more about that. The CSF is formed by the choroid plexus. It passes through apertures in the fourth ventricle into the subarachnoid space. This one is the subarachnoid space. That is, here you have the pia, dura, and arachnoid matter. In between this, we will have the subarachnoid. This white thing is the subarachnoid space. So you have the cerebrum. Cerebrum has the right and left cerebral hemisphere. The right and left cerebral hemisphere respectively contains right and left lateral ventricles. Diencephalon contains thalamus and the hypothalamus. And diencephalon has the third ventricle. It is a narrow slit-like cavity of the diencephalon. The midbrain contains a cerebral aqueduct, and the hindbrain, which consists of pons, medulla, and cerebellum, contains a fourth ventricle. See, this one is the fourth ventricle, which is located in the hindbrain. Hindbrain consists of pons, medulla, and cerebellum. We will study more about that. These are individual chapters. Cerebrum is a chapter, midbrain is a chapter, hindbrain is a chapter. We will study more about that in those chapters. We have only something here. This one is the fourth ventricle. This is the hindbrain. This is the diencephalon. This one, this small thing, is the midbrain. And here occurs the cerebral aqueduct. So we'll look more into this. First, we have the lateral ventricles. There are two lateral ventricles, one in each cerebral hemisphere. Each lateral ventricle is a C-shaped cavity lined by the ependymal cells. See, this is a C-shaped cavity which are lined by the ependymal cells, columnar ependymal cells. Each lateral ventricles communicate with the third ventricle via the interventricular foramen of Monro. We have already discussed that. So we'll come into the parts of the lateral ventricle. See, this one is the anterior horn of lateral ventricle, just located anteriorly. This one is the central part or body of the lateral ventricle. This one is the posterior horn of lateral ventricle, and this one is the inferior horn of lateral ventricle. So we have four parts in the lateral ventricle: anterior horn, central part or body, posterior horn, and inferior horn. See, the inferior horn is the largest one. This one, see this thing. This one is the collateral trigon. We will discuss in the following slide. First, we will discuss about the central part of the body. This green thing is the central part. This green thing is the central part or body. The central part or body lies within the parietal lobe and extends from the interventricular foramen in front of the splenium of corpus callosum. See, corpus callosum lies in close proximity with the lateral ventricle. So you have relations of corpus callosum in every horn. So this one, the central part lies in front of the splenium of corpus callosum. See, corpus callosum has many parts: genu, rostrum, splenium, many. So this one, the central part is located in front of the splenium of corpus callosum. In coronal section, it is triangular and presents roof, floor, and the medial wall. The central part has a roof, has a floor, and has a medial wall. So the relations are the main thing in anatomy. You will come into many relations and many formations in this. So better you will have mnemonic for all this. So mnemonics are the only thing you will remember for exams, because you will have many relations in anatomy and it will fetch you marks. So because relations are such important in exams, also the figures are such important in exams, it will all fetch you marks. This one, so the floor from lateral to medial side is formed by the body of caudate nucleus, stria terminalis, thalamus striate vein, and thalamus. So the mnemonic I put here is CSVT. We will have many mnemonics. I founded this one, CSVT, the body of caudate nucleus. C, caudate nucleus. S, stria terminalis. V is thalamus striate vein and the thalamus. The floor is formed on lateral to the medial side. So we should look the side also. Lateral to medial side is formed by CSVT. Body of caudate nucleus, stria terminalis, thalamus striate vein, and thalamus. Now we will have the roof and the medial wall. Roof is formed by the body of corpus callosum. I already told corpus callosum is in close proximity with this lateral ventricle. So you will have relations of the different parts of corpus callosum. The roof is formed by body of the corpus callosum, and the medial wall is formed by the septum pellucidum. Do you remember septum pellucidum? It is a septum which demarcates the two lateral ventricles, that is the right and left lateral ventricles. See, this one is the central part of the body. Now we will have the anterior horn or the frontal horn. The anterior horn lies anteriorly into the frontal lobe, so it is called frontal horn. Lies in front of the interventricular foramen and behind the posterior surface of genu of corpus callosum. So this one, the anterior horn lies behind the genu of corpus callosum, posterior surface of genu of corpus callosum. It is also triangular in C-section, in coronal section, and presents roof, floor, anterior, medial, and lateral walls. So you will have more relations here. You have roof, floor, anterior, medial, and lateral wall for anterior horn. I'll show you the picture. So the roof, see, this one is the roof, this one is the floor. The roof is formed by the body of corpus callosum. This is the floor. The floor is formed by the rostrum of corpus callosum. The anterior wall is formed by the genu and rostrum of corpus callosum. This one is the caudate nucleus. This one is the putamen and the internal capsule in between. We'll study more about this in the basal ganglia chapter. So the anterior wall is formed by the genu and rostrum of corpus callosum. This is the medial wall, which is formed by the septum pellucidum. This is the lateral wall, which is formed by the head of caudate nucleus. So we'll revise it once more. This is the anterior horn. The roof is formed by the body of corpus callosum. The floor is formed by the rostrum of corpus callosum. Anterior wall is formed by the genu and rostrum of corpus callosum. Medial wall is formed by the septum pellucidum, and lateral wall by the head of caudate nucleus. Now we will have the posterior horn or the occipital horn. It is located into the occipital lobe of the brain. So it is called occipital lobe. It is located posteriorly. See, this one is the posterior horn or the occipital horn. It's located into the occipital lobe. In coronal section, the posterior horn presents medial wall, lateral wall, roof, and floor. So the posterior horn will also have the roof, floor, medial wall, and lateral wall. Here we have something different. The medial wall consists of two convexities, the upper one and the lower one. So you will have an upper convexity and we will have an lower convexity. The upper one is formed by the forceps major of corpus callosum. It is also a part of the corpus callosum. The upper convexity is formed by the forceps major of the upper of convexity is formed by the forceps major of corpus callosum, and the lower one is formed by the calcarine sulcus. Calcar avis is formed by the calcarine sulcus. Now we will have something easy. The roof, lateral wall, and floor. All the three is formed by the tapetum of the corpus callosum. It is another part of the corpus callosum. The roof, lateral wall, and floor is formed by the tapetum of the corpus callosum. So we will have medial wall, lateral wall, roof, floor. Medial wall will have upper convexity and lower convexity, and the floor, roof, and the lateral wall is formed by the tapetum of the corpus callosum. Now I have put many pictures. See, pictures are the most important thing in understanding anatomy. It will fetch you marks. If it is not given the textbook, kindly refer to some internet or Wikipedia. You will get many pictures of this. It will help you to understand it better. So this is the dorsal view. This is the first picture I have told. Brown thing. This is the green thing. This is the first picture. This is the dorsal view. So these are the lateral ventricles. This is the third ventricle, and this is the fourth ventricle. This is the frontal view, okay, and this is the lateral ventricle, lateral view of the lateral ventricle. This is C section. I mean, it is C in shape. It has an anterior horn. The body. This is the posterior horn. This one is the inferior horn, and you will have third ventricle in between. See, this one is more easier to understand. The right and left is cerebral hemisphere. This one is C-shaped, the lateral ventricle. So this one is the right hemisphere. This one is the left hemisphere. We will have two lateral ventricles. This one is the interventricular foramen, which goes into the third ventricle. This one is the fourth ventricle. This is the cerebral aqueduct. This is another thing to know more about the lateral ventricle. This is the frontal horn. This one is the temporal horn. This one is the occipital horn or the posterior horn, and this one is the body. Now the last horn is the inferior horn or the temporal horn. See, this one is the inferior horn or the temporal horn. It is located into the temporal lobe, so it is called temporal horn. In coronal section, it appears as a transverse and presents roof and floor. So inferior horn is easy. It is the largest horn. That means it is the largest horn than posterior horn or anterior horn or the body. So it is the largest horn, and it goes into the temporal lobe. It presents only a roof and floor, so it is easier to understand. The floor is formed medially by the hippocampus and laterally by the collateral eminence. See, hippocampus, we'll study it later. Hippocampus is the memory center, and the collateral eminence. Collateral eminence is just a protrusion of the brain. This is just a nuclear protrusion. So the floor is formed medially by the hippocampus and laterally by the collateral eminence. The roof, lateral part of roof is formed by the tapetum of the corpus callosum, and medial part by the tail of caudate nucleus and stria terminalis. This is the inferior horn. The floor is formed medially by hippocampus and laterally by collateral eminence. The roof is formed lateral part by tapetum of corpus callosum and medial part by the tail of caudate nucleus and stria terminalis. So you have to mug it up, no other way. Now the area where the inferior and posterior horn diverge, this one, the area where the inferior and posterior horn diverge is called collateral trigone. This part is called collateral trigone. I have shown this in the first picture. This is called the collateral trigone. So we have come into the end of lateral ventricles. So this is the lateral ventricle. It is C-shaped, located in the cerebral hemisphere. It has four parts: anterior horn, inferior horn, the body, and the posterior horn, and you will have relations of that. I'll go to that picture once more. So this is the lateral ventricle. This is the third ventricle. This is the fourth ventricle. You will have anterior horn, temporal horn, posterior horn, and the body. Now we will move to the third ventricle, which is the next ventricle. The third ventricle is a narrow slit-like cavity in the diencephalon. So diencephalon, So I think the picture is not so clear. This is the third ventricle. It's located in the narrow slit, I mean, a channel-like thing. Third ventricle. It extends from the lamina terminalis anteriorly to the superior end of cerebral aqueduct of the midbrain posteriorly. So extent is also important. It extends from lamina terminalis anteriorly, lamina terminalis, and to the superior end of cerebral aqueduct. Cerebral aqueduct connects the third ventricle to the fourth ventricle. It extends till the superior end of cerebral aqueduct of midbrain, lining epithelium. So this one is also lined by the columnar ependymal cells. See, all the ventricles are lined by the columnar ependymal cells. And transverse to horizontally by bars of gray matter. The interthalamic are connecting the two, and these are least important things. The two thalamus are connected by a mass of gray matter, that is the interthalamic adhesion. It traverses horizontally in the through the third ventricle. Anteriorly on each side, the third ventricle communicates with the lateral ventricle. So I already told us the lateral ventricle communicates with the third ventricle via the interventricular foramen of Monroe, and the fourth ventricle through the cerebral aqueduct or the aqueduct of Sylvius, Sylvian aqueduct or aqueduct of Sylvius or cerebral aqueduct. The third ventricle communicates with the fourth ventricle via the cerebral aqueduct of Sylvius. So we'll go into the boundaries of third ventricle. The third ventricle has an anterior wall, a posterior wall, roof, floor, and two lateral walls. See, because two lateral wall, because it is located in between the C shape of lateral ventricles. See, the anterior wall is formed from above downward. So you will have to remember this. Anterior wall is formed from above downward by anterior column of fornix, anterior commissure, and lamina terminalis. So this is the third ventricle. This is the anterior commissure. You can see this here. This is the anterior column of fornix and the lamina terminalis. So that this is the anterior wall formed from above downward by the anterior column of fornix, the anterior commissure, and the lamina terminalis. Now we will go into the posterior wall. Posterior wall is formed. This is also from above downward. Posterior wall is also formed from above downward by a pineal gland and the posterior commissure and the commencement of cerebral aqueduct. That means the cerebral aqueduct starts from the posterior wall of third ventricle. So we'll have the pineal gland, the posterior commissure. These are commissures are just tracts of fibers, and commencement of cerebral aqueduct. So the anterior wall is formed above downward by fornix, anterior commissure, and lamina terminalis. Posterior wall from above downward by pineal gland, posterior commissure, and commencement of cerebral aqueduct. Now we will have the roof. We'll have the roof. The ependyma stretches across the upper limits of two thalami. So the roof is formed by the ependymal cells. The roof is formed by the ependymal cells, which stretches across the upper limit of two thalami. Now we will have the floor. Floor will also have many relations. So I have put another mnemonic OTMBT. OTMBT formed from before backward. Floor is formed from before backward by O, optic chiasma, T, tuberous cinereum and infundibulum, M, mammillary body, P, posterior perforated substance, and T, tegmentum of the midbrain. So the floor is also formed from before backward by OTMPT, optic chiasma, tuberous cinereum and infundibulum. See, this is another mnemonic I have found. We'll come across many mnemonics in the Wikipedia, so you can use that. This is the thing I had found convenient for me, so I have put it here. OTMPT, optic chiasma, tuberous cinereum and infundibulum, mammillary bodies, posterior perforated substance, and tegmentum of the midbrain. Now we'll have the lateral ventricle. Lateral ventricle is marked by the hypothalamic sulcus extending from the interventricular foramen to the upper end of cerebral aqueduct. See, the lateral ventricle is formed by hypothalamic sulcus, which extends from interventricular foramen to the cerebral aqueduct. Show you the lateral ventricle. See, this is the floor. This is the posterior perforated mammillary body, OTMPT, optic chiasma, infundibulum, tuberous cinerum. This was the thing. And the lateral ventricle is marked by the hypothalamic sulcus. The sulcus divides the lateral wall into a large upper part and a small lower part. The larger upper part is formed by the medial surface of the anterior two-thirds of thalamus. So the lateral ventricle is divided into a large upper part and a smaller lower part by the hypothalamic sulcus. See the sulcus in the hypothalamus. You already know that the third ventricle is in the diencephalon. Diencephalon contains the thalamus and the hypothalamus. So the hypothalamic sulcus divides the lateral wall into a larger upper part and a smaller lower part. The larger upper part is formed by the medial surface of anterior two-thirds of thalamus. That is, the upper part formed by the anterior two-thirds of thalamus. You can write it like that. The smaller lower part is formed by the hypothalamus. So thalamus in the above side and hypothalamus below. So the larger upper part and a smaller lower part. Upper part formed by anterior two-thirds of thalamus. Lower part formed by hypothalamus. It is divided into larger upper part and smaller lower part by the hypothalamic sulcus. Lateral wall of the third ventricle is divided into two. That is the larger upper part and the smaller lower part. I think it's clear for you. Now we will have another thing, the recesses of third ventricle. See, the recesses means it is just the protrusions. It is just pocket-like extensions of the third ventricle. Just extensions. So it is called recesses. Extensions means recesses. Pocket-like protrusions called recesses. So we will have 5 recesses. The first one is the infundibular recess. It is the recess extending downward into the infundibulum. Infundibulum is the stack of pituitary gland. You have already studied this in the brain chapter. It is the stalk of pituitary gland. Infundibular recess is the recess extending into it is a part of third ventricle which extends into the infundibulum. Now, the next recess is the optic or chiasmatic recess. Optic or chiasmatic recess, it extends into the junction of the anterior wall of the floor of ventricle. See, you know, the floor of ventricle has the first OTMPT, that is the optic chiasma. It extends into the optic chiasma. So it is called optic or chiasmatic recess. Now you have the anterior recess or vulva of the ventricle. It extends in front of the interventricular foramen and behind the anterior commissure. See, commissure are just tract fibers. We'll study more about that in the last chapter. I think all of you are following Visram Singh. So the last chapter contains this ventricular commissure, posterior commissure, and many things like that. So the anterior recess extends in front of the interventricular foramen and behind the anterior commissure. Then you have the suprapineal recess. This is the pineal gland, suprapineal, above the pineal gland. Extends posteriorly above the stack of pineal gland and below the Tela choroidea. See, this one is the suprapineal recess. This one, suprapineal recess, above the pineal glands. It's easy to remember suprapineal. Now we have the pineal recess. It extends posteriorly between the superior and inferior laminae of the stalk of pineal gland. So this is the pineal gland. This is the pineal gland. The pineal recess extends into the pineal gland between the superior and inferior laminae. See, this one is the thing. This one is the thing. Superior and inferior laminae of stalk of pineal gland. See, this one is the infundibular recess. This is the pituitary, hypophysis cerebri of the pituitary. This is the infundibular recess into the infundibula of pituitary gland. This is the optic chiasma. This one, optic chiasma. So this is the chiasmatic recess into the chiasma. This one is the anterior recess. It extends anteriorly in front of interventricular foramen behind the anterior commissure. This is the suprapineal. Fourth one is the suprapineal recess. This one, suprapineal recess, and this is the pineal recess, above the pineal gland, and the pineal recess into the pineal gland, between the superior and inferior laminae. Now we will look for the Tela choroidea. See, Tela choroidea has this one choroidal plexus. The Tela choroidea in the roof of third ventricle is triangular in shape. See, this one is the lateral ventricle. This one is the thalamus. This one is the choroid plexus of the third ventricle. We will study more about choroid plexus and Tela choroidea. Choroid plexus are usually spiral in shape. The choroid plexus of third ventricle hangs downward from the Tela choroidea as two longitudinal anterior-posterior vascular fringes. See, you can see this. 1, 2. So the choroidal plexus of the third ventricle hangs downward from the Tela choroidea. This is the area. This area is called Tela choroidea. This extension where the choroidal plexus are situated is called the Tela choroidea. So the choroid plexus hangs downward from the Tela choroidea as two longitudinal anterior-posterior vascular fringes. Anterior and posterior vascular fringes. That is, hangs as two extensions from the Tela choroidea. Now have the applied aspect. See, for every questions, even if they didn't ask the applied aspect, you have to write any one of the applied aspect. It will fetch you marks. Sure, it will fetch you marks. See, anatomy is so easy to study. The things you need is picture. It's a must for every question. Even if you didn't write something, if you draw some pictures, you will get some marks. No, I mean not full marks. You will get some marks. Then the applied aspects. Then this one, pictures, applied aspects. This relations will fetch you marks. If you write the relation correctly, you will get more than half of the marks. These are the important things to get marks in anatomy. Anatomy is an easy subject. So then the applied aspect, obstruction of third ventricle. It's obstructed by the local brain tumors or congenital effects. See, tumors are all second year subjects. So the third ventricle can be obstructed by local brain tumors. A tumor in the brain can obstruct the third ventricle. This obstruction results in excessive accumulation of CSF inside the brain, resulting in increased intracranial pressure in adults and in hydrocephalus in children. So we'll go for an example. Suppose a balloon, you will have suppose a water balloon, you will have water in that. If you fill water again into that balloon, the pressure will increase and it will burst off. Like that, the obstruction results in excessive. So because of the obstruction, CSF cannot go to the subarachnoid space. So accumulation of CSF occurs in the third ventricle, and it results in the increased intracranial pressure in adults and in hydrocephalus in children. So here ends the third ventricle. So the site of obstruction can be found by ventriculography. It is a method to find out the site obstructed by the local brain tumor. So here ends the third ventricle. So we will have a quick recap of the third ventricle. The third ventricle is a narrow slit-like cavity of the diencephalon. It is a quick. This is the narrow slit-like cavity of the diencephalon. It will have ependymal cells lining it. Then the lateral ventricles are connected to the third ventricle by the interventricular foramen of Monro, and the third ventricle is connected to the fourth ventricle by the cerebral aqueduct of Sylvius. Now you have the anterior wall, posterior wall, roof, floor, and two lateral walls. Among this, floor is the most important. OTMPT, I have given mnemonic for that. You can study it as you want, because this is not only the mnemonic. You will find many mnemonic in the YouTube or on the Wikipedia. Now the recess, you will have 5 recesses: the infundibular recess, optic or chiasmatic recess, anterior recess, suprapineal recess, and the pineal recess. Now the last is the Tela choroidea and the applied aspects. So here ends the third ventricle. Now we will go for the fourth ventricle. This is the important topic in the ventricle chapter. Fourth ventricle is an important topic. We'll get it for sure 5 marks or 10 marks. Not 10, I mean 15 marks. See, this is the fourth ventricle. I'll show you. The fourth ventricle is located in the, see, fourth ventricle is located in the hindbrain. It is a 10-like cavity of the hindbrain lined by the ependymal cells and filled with the CSF fluid. As just like the ventricles, it is lined by the columnar ependymal cells and filled with the CSF. It is situated in the posterior cranial fossa. We'll have anterior cranial fossa and posterior cranial fossa. The fourth ventricle is located in the posterior cranial fossa in front of the cerebellum. So this one is the cerebellum. This bulb-like thing is the cerebellum. We'll have another class on cerebellum. It is another big chapter. And behind the pons and the upper part of medulla oblongata. So behind the pons, in front of the cerebellum. So in front of the cerebellum, behind the pons. It appears as rhomboidal or lozenge shape in horizontal section. So in horizontal section, this is the horizontal section. It appears as rhomboidal. You know rhombus in max, no? Four-sided thing. It's diamond shaped. Rhomboidal or lozenge shape in horizontal section. It is continuous inferiorly with the central canal of medulla oblongata and superiorly with the cerebral aqueduct. We have already discussed this. Here, the fourth ventricle continues with the central canal of medulla, I mean the central canal of spinal cord, and it extends in the conus medullaris. And superiorly, we have the cerebral aqueduct of Sylvius, which is connecting the third ventricle and the fourth ventricle. Its roof possesses three important openings, which permits the CSF to escape from the ventricular system of brain into a subarachnoid space. This also we have discussed earlier. From the fourth ventricle, the CSF or the cerebrospinal fluid will escape into the subarachnoid space. Now, the most important thing is the boundaries. First, the lateral boundaries or the lateral wall. Inferolaterally by the inferior cerebellar peduncle, supplemented by the gracile and cuneate tubercle. See, inferolaterally, this is inferior side, this is the superior side. Inferolaterally, this is the lateral side. Inferolaterally by the inferior cerebellar peduncle. This is the inferior cerebellar peduncle. These are all just tracts or the fibers. Inferior cerebellar peduncle supplemented by the gracile and cuneate tubercle. You will have gracile nucleus and cuneate nucleus, and the tubercles of that is called gracile nucleus, I mean gracile tubercle and the cuneate tubercle. Suprolaterally, this is suprolaterally by the superior cerebellar peduncle. This is the superior cerebellar peduncle, suprolateral. This is the inferolateral. This is the suprolateral surface. So these are the lateral walls. This is the superior cerebellar peduncle. Now the roof or the posterior wall. The roof of the fourth ventricle is 10 shaped. This is very important. It is 10 shaped with the lower sloping surface. The upper part of the roof is formed by thin sheet of white matter. The superior medullary vellum that stretches between the two superior cerebellar peduncles. So this is the superior cerebellar peduncle. The upper part is 10. So 10 will have, you have seen this 10 like thing in some functions. No, 10 like thing. It look like a cone. So the upper part of roof is formed with thin sheet of white matter. You all know white matter and gray matter. The superior medullary vellum stretches between the superior cerebellar peduncle and covers the upper part of roof. The superior medullary vellum is formed by thin sheet of white matter. The lower part of roof is formed by the inferior medullary vellum. So the upper part is formed by superior medullary vellum. The lower part is formed by the inferior medullary vellum, that is formed by the ventricular ependyma and the pia mater. The lower part, see, the lower part of roof is perforated by a midline slit, the median aperture called foramen of Megandy. So these are important foramens that helps for the escape of CSF from the fourth ventricle into the subarachnoid space. The upper part of roof formed by superior medullary vellum, lower part of roof formed by the inferior medullary vellum. The lower part of roof has one midline slit and a median aperture called the foramen of Megandy, through which the cavity of fourth ventricle communicates with the subarachnoid space. So the CSF from fourth ventricle goes into subarachnoid space through the foramen of Maganti. It is an important PG question also. Foramen of Maganti is located in fourth ventricle. So the cavity of the fourth ventricle is prolonged laterally and opens as lateral aperture or foramen of Leschka into the supraarachnoid, into a subarachnoid space. So then we have first aperture, foramen of Maganti. Then we have the next aperture, the foramen of Leschka, which is a lateral aperture. This one is midline aperture. This one is lateral aperture. So Leschka lateral. Can remember like this. LL. Lateral aperture is foramen of Leschka. Medial aperture MM. Maganti. Foramen of Maganti. Through foramen of Maganti and foramen of Leschka, the CSF will enter into the subarachnoid space. See, CSF cannot accumulate in the fourth ventricle. CSF want to go to subarachnoid space and into the spinal cord. So from the fourth ventricle, the CSF will escape into the subarachnoid space by the foramen of Maganti and the foramen of Leschka. Foramen of Maganti in midline and foramen of Leschka in the lateral. CSF escapes from ventricular system to subarachnoid for absorption by arachnoid villi. So the CSF will be absorbed by the arachnoid villi and granulation, which we will be studying this in later classes. Now, this is the most important 5-mark questions. Features of fourth ventricle. So you can see this. This is the lozenge shape or rhomboidal shape or diamond shaped cavity of the fourth ventricle. See, diamond shaped. This is the superior cerebellar peduncle. We have already discussed that. This is the inferior cerebellar peduncle, cuneate and gracile tubercle. So we'll go for the features of fourth ventricle. First, the floor is divided into right and left symmetrical halves by a median sulcus. See, this one, the line going in the midline. This is the median sulcus. So it is divided into right and left symmetrical halves, which extends from the aperture of aqueduct of midbrain. So extends from the aperture of aqueduct of midbrain to the commencement of central canal below. So the cerebral aqueduct, which continues as the fourth ventricle, which again continues as the central canal. So it extends from the aperture of aqueduct above and the commencement of central canal below. At its wider part, the floor is closed transversely by glistening white fibers, the stria medullaris. So this one is the stria medullaris. This one is the stria. These are white fibers which are crossing transversely in the middle. So the median sulcus is crossed transversely by the stria medullaris. The fibers of stria medullaris are derived from the arcuate nuclei and run transversely across the floor to enter into the inferior cerebellar peduncle. So this is the inferior cerebellar peduncle. We have already discussed that. The stria medullaris are white fibers that run transversely to enter into the inferior cerebellar peduncle. These fibers of the stria medullaris, these fibers are derived from the arcuate nuclei. We will have many nucleus. Don't get confused. This is the arcuate nuclei. This is the cuneate nuclei, gracile nuclei. Then on either side of the medial sulcus, there is a longitudinal elevation called medial eminence. So this one is the medial eminence. This is the medial sulcus. This is the medial sulcus. On either side of the medial sulcus, you will have eminence. Eminence means protrusion. Eminence, that is the medial eminence. Elevation or protrusion is the medial eminence on either side of the median sulcus. The medial eminence is bounded laterally by sulcus limitans. I'll show you this one. This is the medial eminence. This is the medial eminence. The medial eminence is limited laterally by sulcus limitans. See, this one is the sulcus limitans. This is the median sulcus. This is the medial eminence. The medial eminence is laterally limited by sulcus limitans. Now the fifth point, the lateral ankle of floor, the region lateral to sulcus limitans overlay the vestibular nuclei. So you will get another nuclei here, vestibular nuclei, hence it's called vestibular area. I'll show you. See this one, the most lateral to the sulcus limitans, there is the vestibular nucleus, and this area is called as the vestibular area. Don't get confused. At the lateral ankle of floor, the region lateral to sulcus limitans. So it is the region lateral to sulcus limitans overlies the vestibular nuclei, and hence it is termed as vestibular area. Now the upper end of sulcus limitans widens into a triangular depression called superior fovea. Above the superior fovea, a bluish gray area called locus coeruleus. So you can this one, the upper end, this one, the upper end. See this gray thing. You can see a small thing. The upper end of sulcus limitans extends to superior fovea. Can you see this? This thing is superior fovea. Superior fovea. Above the superior fovea, a bluish gray area called locus coeruleus. Why it is bluish gray? The color is imparted by the underlying group of nerve cells containing melanin pigment, which constitutes a substantia ferruginea. See, ferruginea, you will don't think that it contains some iron. It is substantia ferruginea. Uh, it contains the melanin pigment. Melanin, you know the melanin pigment. The melanin pigment is imparted by the underlying group of nerve cells, which in turn give the locus coeruleus the bluish gray color. Now the 7 point, the lowermost part of sulcus limitans present a small depression called inferior fovea. So I will show this. See, you'll get a big picture here. I'll show you once more. So this one is the median sulcus. This is the medial eminence. This one, so the medial eminence is limited laterally by the sulcus limitans. Lateral to sulcus limitans, you will have the vestibular area. Above vestibular area, you will have superior fovea. Above superior fovea, you will have the locus coeruleus. Locus coeruleus is bluish gray in color. The color is due to melanin pigment due to the underlying group of nerve cells and called substantia ferruginea. Okay, so this is the superior cerebellar peduncle, sulcus limitans. This is the medial sulcus, medial eminence. Medial eminence is limited laterally by sulcus limitans. This is the vestibular area. This is the stria medullaris. This is the inferior cerebellar peduncle. I will move more into that. On either side, the medial eminence presents an overswelling called the facial colliculus. It is produced by the motor fibers from motor nucleus of facial nerve hooking around the abducent nucleus, internal genu of facial nerve. It is very important. So I will show you. This one is called the facial colliculus. This eminence on either side of the median sulcus, you will have an eminence called the facial colliculus. See, colliculus is just a group of nerve fibers. It is formed by the fibers from the motor nucleus of facial nerve. Motor nucleus of facial nerve hooking around the abducent nucleus. So I'll show you this thing. Sorry. So this one will be the abducent nucleus. This one will be the abducent nucleus. Here we will have the abducent nucleus. The motor nucleus from the facial nerve will hook around. This one will hook around like this. Here also both sides will hook around. This is the facial colliculus. Will hook around. See, the motor nucleus of the facial nerve. This is the motor nucleus of fibers coming from the motor nucleus of facial nerve hooking around the abducent nucleus. This is called internal genu. It's called hooking around the abducent nucleus. Internal genu of the facial nerve. This is the internal genu of the facial nerve hooking around the abducent nucleus, and it forms the facial colliculus. Okay, then the medial sulcus divides the medial eminence in the medullary part of the floor into two triangles, the hypoglossal triangle above and the vagal triangle below. I'll show that. We'll show that. This one, a hypoglossal triangle. This one is a hypoglossal triangle above and a vagal triangle below. So this one is the hypoglossal triangle. This one is the vagal triangle. This is the stria medullaris, which which crosses transversely in the floor of fourth ventricle. So the median sulcus divides the medial eminence in the medullary part of floor into two triangles, the upper hypoglossal triangle above and the vagal triangle below. The vagal triangle overlay the nuclei of vagus, glossopharyngeal and cranial accessory nerves. So the vagal triangle will have the nucleus of, so we have found about 5 nerves here. Here comes the facial nerve, abducens nucleus, abducens nerve. In the vagal triangle over here we have the nuclei of vagus, glossopharyngeal and cranial accessory nerves. Now the vagal triangle it's located below. The vagal triangle is crossed by a funiculus separatus. A small area between the funiculus separatus above and gracile tubercle below is called area prostrema. I'll show you that. See, funiculus separatus. This one. This is the funiculus separatus. Here you have the inferior fovea. This is the vagal triangle. This is the area postrema. The funiculus separatus which separate the vagal triangle into two. This is the area postrema. So the vagal triangle is crossed by funiculus separatus as I have showed you. The small area between the funiculus separatus above and the gracile tubercle below. That means it is above the funiculus separatus in the above part and the gracile tubercle below is called area postrema. Now the infralateral margins are located by a narrow white ridge called tinea. See this one, infralateral. This is the infralateral. You will have a small area called tinea. The two tinea meet at the inferior angle of ventricle to form small fold called obex. To show you. See this one. This is the obex. The two tinea meets at the infralaterally. Most infralaterally, you will have the obex. This triangle thing is the obex. This is the funiculus separatus, which separates the vagal triangle. It divides the vagal triangle. This area above this area in between the funiculus separatus and inferior cerebellar peduncle is called area postrema. Area postrema. So we will discuss it once more. First, this is the rhomboidal shape floor of fourth ventricle. This is lozenge shape or diamond shaped or rhomboidal shape. We will have the median sulcus. This one is the median sulcus, which divides into two. This is the inferior colliculus. Coming from inferior colliculus is the superior cerebellar peduncle, supralateral margin, infralateral margin. This is stria medullaris, which crosses the floor transversely. This is the medial eminence. The medial eminence is limited laterally by this one, sulcus limitans. This is the vestibular area. This is the superior fovea. Above superior fovea, you have the locus coeruleus. Locus coeruleus is bluish gray in color due to melanin pigment of substantia ferruginea. This one is the so this one is the tuber cinerum. This one is a tuber cinerum. This is the stria medullaris. Below the stria medullaris, you will have an upper hypoglossal triangle and a lower vagal triangle. Lower vagal triangle will have the nucleus of vagal nerve and the glossopharyngeal nerve. So this one is the vagal triangle. This entire thing is vagal triangle. The vagal triangle is divided into two by funiculus separatus. This is another tract of fibers, funiculus separatus. The area between the two funiculus separatus and the inferior cerebellar peduncle is called the area postrema. This is the gracile tubercle. This is the cuneate tubercle. This is the infralateral margin. So this is the most important part of this class. It is the features of fourth ventricle. Now the most infralateral area called obex. The obex forms the roof of inferior angle of the fourth ventricle. We already discussed that. So this is the fourth ventricle. This is another section. Now the applied anatomy of fourth ventricle. The third ventricle also we have applied anatomy, that is obstruction due to tumor. The most here in the fourth ventricle, tumors of fourth ventricle. The most common tumor in this area is medulloblastoma. It arises from poorly differentiated primitive neuroectodermal cells of cerebellar vermis It occurs mostly in children. It occurs in children. It is a medulloblastoma. It is a tumor. Tumors will obstruct the CSF from escaping into the subarachnoid space. This causes cardiac irregularities, tachycardia, irregular respiration, and vasomotor disturbance. The ependymoma arises from this is another thing, another tumor. There are two tumors of fourth ventricle. First is the medulloblastoma. It arises from the neuroectodermal cells. It is found in children. Then the ependymoma, it arises from proliferation of ependymal cells which lines the cavity of fourth ventricle. It may cause obstruction to the flow of any tumor which occurs in the ventricles will obstruct the flow of CSF. That is, CSF cannot escape into subarachnoid space, so CSF will accumulate in the ventricle, which causes in the rise of intracranial pressure and hydrocephalus in children. This is the same thing as in third ventricle, so you can write this same as that of third ventricle, but here we have the names for tumors: medulloblastoma and ependymoma. Now you will have important university questions. I have found it from many textbooks. The most important essay questions will surely get, if it's not an essay question, it will be a 5 mark, sure 5 mark. The fourth ventricle, its boundaries, features of rhomboid fossa. That is a rhomboid fossa or diamond fossa. We already discussed that with the help of diagram. So you want to draw the diagram. You want to first um, describe about the fourth ventricle. Its extent, its boundaries. Then comes the rhomboid fossa. You want to draw the picture and the features. I have told you about 12 points like the sulcus limitans, then median sulcus, medial eminence, facial colliculus, like that. You want to see point-wise presentation of answers will fetch you marks for sure. So better write in points. Don't, if you are sure about the answer, write in points. Don't go for paragraphs. Now, short notes. Rhomboid fossa is again the same question. Fourth ventricle. If fourth ventricle is asked, you want to write also the rhomboid fossa. Then the third ventricle, horns of lateral ventricle. We have discussed that. Posterior horn of lateral ventricle, and the recesses of third ventricle. You have 5 recesses. This is a horn for lateral ventricle. You have the posterior horn, inferior horn, anterior horn, and the body or the main part. I have took references from here. The most suitable book for studying anatomy is of course Visram Singh, because you will get many pictures, you will get many points in that. I don't know how many of you are following BD Chaurasia, because we followed Visram Singh textbooks. Also for embryology, it is a good. Yeah. We also followed Inda Singh, but Visram Singh is also good. And thank you. We have come to the end of the class. Thank you all for your listening.